The iTripSystem, Mainetec started out in 2010 predominantly as a rebuild facility, specialising in shovel dipper rebuilds and excavator buckets. But predominantly with the shovel dipper rebuilds, we started working with customers and enhancing existing designs and just making changes where we could. And the evolution of those changes led us to developing a system and calling it the iTrip system. It's not just the tripping mechanism, which is in the bottom of the screen there. That is the tripping mechanism which opens the door when the operator presses the button. But we also made improvements to the door hinge system and the equalizer or the equalizer system or the padlock for a cat machine. And those specifically those changes to the top items there that enabled the dipper to stay on the machine for longer. Really good improvements, and you'll see in future slides coming up that the longevity and of the hang time of the dippers increased just through those designs. We're just going to go through the iTrip latch system to begin with in a bit more depth. And where that green arrow is pointing to there, that's basically the latch keeper. And if you think of the door just like a door in your house or in a car, it's got a latching mechanism and it's got a receiver. So the receiver in the dipper body there is what the latch bar latches into. And that's how you set your engagement. And then when the operator presses the button, that wire rope lifts that lever, just like you lift the lever in your car or your door handle, and that's what opens the door. So when you remove the door components, and these are the consumable components, I suppose you would say, on the right-hand side there, typically it's a latch lever. That's where the rope mechanism goes through that sheave at the end, and that raises the lever. There's a fulcrum point on the left-hand side of the lever there, and that slides the latch bar up and down. So that image on the right-hand side there, everywhere that's green is a poly product, which traditionally was steel, and that steel on steel was what creates the friction and the difficulty with tripping. So when we put these poly products in, it just allows for a smoother, less resistance to tripping, and then we can create a deeper engagement with the latch bar into the latch keeper, and therefore less shimming events. And that image on the left is just that latch lever disassembled view. Some benefits of the evolution of the system, and this was built from the ground up, a lot of time on sites. Pretty much every photo in this slide is taken by myself or one of our team members where we've gathering data, looking at what works, looking at what didn't work, and refining the system with the help of our customers. And basically, through increased service life of the individual components, our goal was to increase service life. That's led to the benefits that we see, which is reduced shimming and the shimming intervals and the less service intervals. We can take clients from 2-week services to 4-week services, and then reduce rebuild costs when it does come time for a rebuild. We can reuse some components, and there's components that don't wear out anymore. And there's the ease of maintenance, and the improved production comes through pretty much through less downtime, less breakdowns, and less shimming events. Just breaking it down a little bit more deeper into the actual latch bar. Latch bar, typically the old system, the old style was 16 weeks, and it used to cop a lot of friction. And you'll see that swirling metal on metal wear on the left-hand screen there. That's from the interaction with the green lever. That's where the interaction, it just leads to friction and poor tripping setup. And on the right-hand side there, that's the slot in the latch bar again, where that lever interacts with that face. And when it's all set up nice and it's running on the poly surfaces that we have in there, it just doesn't encounter any friction or wear. So we can extend that life up to 48 weeks is pretty standard, but we have seen dippers leave and come back for a rebuild after 72 weeks with the same latch bar still in there. That's that lever interface on the left-hand side there where it runs through that latch bar with the old fulcrum setup and the old metal on metal up top there. Everything about there is just friction and wear, and then you have to shim to compensate for that wear. And the one on the right there, that was a latch lever that was removed just so we could have a look at it, take some photos, and it went back to service. And that lever, typically those latch levers last up to 48 weeks, and even beyond that. We provide maintenance strategies for components to be replaced as part of this package, and yeah, some people choose to run beyond that, and that's where we get the big numbers like 76 weeks at times.
So Dan, just to reinforce there a little bit, I know that people can see that you mentioned there it's been removed where you've taken the photo just for an inspection. So just for the audience that may not be familiar, that section of polished steel on that top radius is basically all the wear that was experienced after 48 weeks versus what you can see in the OEM picture in the black and white there. So that is not a new iTrip system on the ground. That has done 48 weeks of service, and all the wear that has been experienced is that polished surface on that top radius, correct?
Correct. And those, you can see those wear buttons that we have in the face there where it's not worn. That's what those wear buttons have done their job there and protected that face. And the upper surface there is running on a poly surface up on the upper of the latch bar, which does a lot of work. It's surprising how little wear it gets. And then through the extended trip rope life, it gets back to this ease of tripping. And if you talk to any operators that run this system, shovel operators, they always comment on how nice it trips. So again, when the operator presses the button, the trip rope pulls on the standard sheave arrangement there. You know, you've got like 25 mil of play between the throat of that sheave and the thickness of the latch lever that we're looking at end on there in this view. And on the right-hand side, the iTrip, we've tightened that tolerance right up. Our latch levers are actually 60 millimeters thick versus 50, and the throat thickness on our sheaves is something like 63 millimeters. It's quite refined. And we also have replaceable poly little top hat bushes that go into the sheave, so we can renew that fit once we get a bit of wear there, and then that sheave remains in that upright position. When the operator presses the button, it's just a direct trip. It doesn't have to first stand that sheave up. That's an actual case study down there in inverted commas. Those guys ran side by side, one system with their old setup and one system with iTrip, and there was a big saving in trip rope life and trip rope replacements and therefore downtime. This is planned maintenance. So planned maintenance with the standard system, with the wear that you see in the fulcrum setup, you have to rotate your latch lever and fulcrum C block every 4 weeks and replace every 8 weeks. And the latch bar was the same. It was around that 16-week replacement mark. So just by running the iTrip system, the planned maintenance was reduced to 145 hours over a 48-week campaign. And then just in those same component replacements for planned maintenance, we were nearly close to halving the cost of planned maintenance components.
And just for the audience, Dan, you mentioned there a couple of times planned maintenance. So this is not taking into consideration, this is a very conservative approach in regards to the iTrip review. This is not scheduling or considering any of the benefits from that unplanned kind of breakdown type events, correct? This is just based on for like planned maintenance scenarios, not considering any breakdowns.
And that's correct. And that's the iTrip there at a 2-week maintenance interval. And we've actually lowered that further with some later changes that we've made to the lower latch bar insert, where we've been able to push that out to 4 weeks. And that makes a huge difference with the maintenance hours. And this is just to highlight that from that beginning slide, the equaliser system and the door pin system, which have both key components to the hanging the dipper for longer and achieving that. So the door bush, static door pin upgrade. So basically it's quite simple. It's just a longer pin. The collar gets welded to the dipper body. The pin no longer rotates and the door bush is replaced with a self-lubricating poly bush. So when it does come to rebuild, the door pin hardly has any wear in it. You can actually reuse it. Just replace the poly door bush, and those steel bushes don't require replacement because they don't see any wear anymore. There's no rotational wear.
And typically, Dan, what if it was not installed with the poly bush, what type of life expectancy or what type of maintenance would you see the guys with lubrication having to go up and maintain those pins?
Oh, some sites lubricate their doors every single day manually, stop the machine and lubricate the door manually. Other sites, there is some lubrication systems that haven't been successful over the years that operate. You've got to fill the pod with grease and whatnot up on top of the machine and the door activates it. They're very problematic. And then if you just run steel without any lubrication, typically what you'd see is when the door drops because of wear, you run into problems with latching, and your door will catch on the dipper body because it's physically contacting areas where it should have clearance, or you'll actually run out of travel in the shim box where you can't keep that latch bar engagement because the door's dropped that much. And that photo on the left is that the bush is worn far through the bush and into the parent metal. And on the right-hand side there, that's a poly bush after an 18-month campaign. Yeah, still quite healthy.
So massive safety improvements as well as the 3 bullet points there, less downtime, more hang time, but some massive safety improvements as well with operators not having to get up there and perform those inspections and lubrication, correct?
Yeah, absolutely. This is the same sort of thing, but instead of the equalizer on the front, which we have on a P&H dipper, this is a cat dipper there with the padlocks. While there's no poly in here, when the padlocks move with every single load, that rotational force wears out the center lug there. It's got an arrow pointing to it on the right-hand side there, and it just can't handle it. Just by locking up that pin, you take out that rotational wear, that center bush doesn't wear anymore. So we could go from 16 weeks to a full campaign, 18 months.
Dan, I'll give you a breather. So I guess one of the things, the iTrip system has a whole lot of moving parts and a whole lot of improvements. One of the things that Austin does, not only with the dipper buckets and the iTrip system, but with all of our parts, we provide some detailed part breakdown for any component or any attachment that we manufacture. And as you can see on the screen here, the picture on the left is the current dipper that's about to leave the shop this week. And you can see a parts breakdown there. And on the right-hand side of your screen, you can see the iTrip system broken down with part numbers at the top, which then refer to part numbers underneath in regards to a box showing you the itemized part breakdown. And that is something that's pretty standard with all of our proposals that go out the door, just to give you that confidence. And I guess, Dan, each and every single one of those parts has, I guess, a written document behind it that gives some confidence for the end user in regards to inspection and maintenance regimes and replacement strategies, correct?
Yeah, correct. Some of them are just simply replaced on condition, but the bigger parts, we have a planned maintenance strategy.